discuss is the graph of F and T. So FT graph. So what is FT graph? The force and time graph. So suppose we have a force time graph like this. Suppose this is force time graph is given like this. So what the force time graph indicates and how this is related with other quantities such as momentum. So we had written that F is dp by dt. So if we write dp, that will be F dt. So integration of F dt is going to give change of momentum. So change of momentum is integration of F dt. So that is area. So area under graph. So integration is same as area, and integration is also change of momentum. It means the area under graph is going to give change of momentum. Area under FT graph is going to give change of momentum. So that can be used also. So we will see an example. Suppose we have a FT graph given. This is suppose 5 Newton, and this one is suppose 8 Newton, and the time here is given. This is 0 second and this is 10 second, and an object of mass. According to this graph, suppose we have a question, an object of mass m equal to 2 kg is moving with speed, moving with velocity 3 meter per second initially, 3 meter per second initially. Then a force is applied. A force is applied which is given by above graph. Given by above graph. Given by above graph. Find velocity of object after 10 seconds. Find velocity of object. Velocity of object after 10 seconds. So how do we solve this kind of question? So in this question, force is not constant. So you cannot simply write F equal to ma is correct, but for velocity you need to integrate those things, and you need to have expression for force. So it is better to use area under the curve, because area you can directly find from this graph. If graph is given, you can directly find the area, and the area here, this area is going to give the change of momentum, and the change of momentum can be used for finding change of velocity. So what we will do is, if we write change of momentum, that can be given as area under graph. So what will be area under graph? So this is trapezium shape. So its area will be half into height. So height is here, this one, the 10 second, and sum of parallel sides. So sum of parallel, so one side is 5, other side is 8. So 5 plus 8. So this much we are getting. So this is the area under graph. Now this area will be equal to change of momentum. So first let us calculate the values. So it will be 5 plus 8, 13, and 13 into 5. So 65 Newton second we are getting. Or we can see, we can write it kg meter per second. So this is the change of momentum. Now the change of momentum we can write in terms of velocities also. So suppose initial velocity is u or final velocity is v. We can write final velocity mv minus initial velocity mu. That will be equal to 65 Newton second. And mv, how much is m? M is 2 kg. V we need to find. M is 2 kg and v we need to, u is given 3 meter per second, and that is equal to 65. So if you solve it, you are going to get 2v, and this is 6, so it will be 65 plus 6, or you will have v equal to 71 by 2. So it will be 71 by 2. So that is 35.5 meter per second. So this much we are going to get. The velocity will now become 35 meter per second at the end of 10 seconds.